Okay, so what we were doing was performing some kind of request to the Modbus simulator using mbtget. What we are going to do now is use another tool that is included in the Metasploit framework. So as it takes a long time to launch Metasploit in the VM, I suggest that you start by typing in MSF console right now. Okay, so these were the commands used to perform Modbus queries, and now we're going to switch to the next one. So we're going to launch MSF console and then use the Modbus client, which is an auxiliary module. Still not loaded. Okay, so I'm going to play around a bit and change the values. Okay, so here I have the Metasploit console. Is it okay for everyone? Have you been able to launch it? Okay, so I will use an auxiliary module that's into scanner, Scada, and then it's Modbus client. By typing in info, you can have some information on the module. So there was previously a Modbus client module that only allowed people to write values to coils, so that was kind of limited. So I, let's say, I modified it, so it's now part of the. It's not part of the Metasploit framework. So how to use it? First of all, you have to take a look at what kind of action you can do. So show actions, I think. Yes. So you can read coil, read the register, write to a coil, or write to a register. So, for example, I'm going to set action to read the value of a register. Then I'm going to take a look at the options. So, of course, you need to set up your target. So, once again, it's going to be localhost. You have to set the data address where you want to read. For example, for me, let's say I want to read value at 5, maybe. And then you just type in run. That's how you run the auxiliary modules. And as you can see, the value stored at the register number 5 is 4, which is funny because, yes. Okay, so let's try something else. The previous address, and it's 3. So yes, you can see that those are the values that I queried. Maybe it's not interesting to but to, let's say, to spend too much time, I'm just going to show you that you can modify the action as well. Write register. And then I have to set the data. Let's say I want to write 1 to 3. Data address is 4, and then I run. As you can see, it says that it succeeded, and it is true. Have you been able to do the same for those of you who are following?
How do you write hopeless clients?
Oh, okay, sorry. Okay. I'm going to try to, well, I do not know how to make the text bigger, but it's Modbus client in one word. Everything is lowercase. I'm sorry, control? Nope. Yeah, but yes. So here it, and I'm guessing control minus is for lowering the size. Let's say my keyboard mapping is very specific. Anyway. So let me just go back to the slides. Yeah, so that was on the simulator. Now I think it's time to try to move on to the real PLCs. There's something very important to know. You should never perform any test on a live ICS systems because there are so much at risk. Usually what you can do is try to do your test on a lab like this one, or you can try to do the test during a maintenance phase of a plant or a factory. In my experience, most factories shut down at least 1 week each year. So try to, I know it's difficult, but you can try to plan your test during this specific phase. Okay, so the first phase would be the recon. So we're going to try to do a port scan and identify the ICS on the network. So I just plugged in a Wi-Fi access point. Sorry. So here you have the SSID and the password. Just try to connect and tell me if it works. Yeah, it's kind of a funny SSID. Is it okay for you? Did you succeed in connecting? If so, you can try to ping the two PLCs. Here you have the IP addresses. It's .5 for the Schneider and .50 for the Siemens. They should answer to ping request. Let me try. Yeah, works for the Schneider and for the Siemens. Okay. YOLO swag. I'm going to put it again. Okay, so let's start with using Nmap. So Nmap is the de facto tool for performing any kind of reconnaissance or let's say port scanning. However, it can be quite harmful to do so on ICS. On a related subject, once I was doing some penetration tests on building automation, and I just did a Nmap full TCP port scan of one. It was kind of a PLC that was handling the lights and the air conditioning of the building, and then Nmap started hanging and the phone started ringing. So when you do a pen test, you know that when the phone rings, it's never good news. So actually, all the communication cards just crashed, because most of the time when you're talking ICS, the devices have, let's say, some weak TCP/IP stack, so it's quite easy to perform a denial of service, sometimes only by performing an Nmap scan. You can find also two interesting stories from the NIST standard about people trying to perform penetration tests on ICS. In one case, they lost for $50,000 of material, and on the other incident, a penetration tester just made there was a big problem with gas distribution, so for several hours the company was not able to distribute gas. So yeah, that was kind of a big deal. So what you can do to prevent this kind of incident, you can use the switch scan delay, which will really make the scan go slower, but it's also safer. You should do a TCP scan instead of a SYN scan, because when you do a SYN scan, for some devices, they will try to keep the connection open for a long time, since you never do the full handshake, and that's going to crash them. And also try not to use any fingerprinting function, and if you have to use some Nmap plugins, be wise in the selection of those plugins. So yeah, that's the theory. However, here, let's say on this small lab, we're gonna try to be quite fast. So I'm gonna fire Nmap. So you see, if I input scan delay equals 1. And then I'm gonna try to scan the, let's say, the Siemens. Yeah, you can also input, use the N switch to prevent DNS reverse looking. So as you can see, it's really slow, and I'm using a direct Ethernet cable on a local network. So it's really slow, but let's say it's safe. For today, I'm just going to do a classical Nmap scan. Yeah. So as you can see, the only open service found was HTTPS. That's because we did not perform a full TCP scan. So if you want to actually scan all the ports, we have to use the P switch. Now I'm going to do a full TCP scan. If it does not take too much time. Yeah, it's quite long, so I'm just going to give you the answer. Yeah, so the two ports that you should be able to see in TCP are 443, that's used for HTTPS, and 102, that's actually the proprietary protocol that Siemens uses to communicate with the programming software. If I do the same for the, let's say for the Schneider, you should be able to find some FTP, HTTP, and some Modbus ports. Yes, they are all open. Does that work for you also? Okay. Okay, so I just cheated because I wanted to get fast on the Nmap scan. You can also find online some specific Nmap scripts for ICS. I know that Digital Bond released some recently. I think it's a project called Redpoint. So that could be a nice resource to take a look at. And now we're going to use a different tool that is specifically designed for ICS. It was made from the Scada Strangelove team. It's called PLC Scan. So it's not like Nmap, so it's not going to find all the open ports. It's just going to focus on the Modbus port and the port used by Siemens. So it's only port scanning 2 ports. But since these are legitimate requests, there's really a low chance that you will crash anything by doing that. So what you can do is go to the tools directory, and then you should have PLC Scan, I think. It's a Python script, so you can take a look at the source code if you want. Take a look at the help. But anyway, I'm just going to do a classical scan. So I'm going to scan the whole range. So it's 0/24. So as you can see, it's not really fast. It takes one IP after one IP and tries to communicate with the port 102 or 502. So quite quickly we can see that the Schneider PLC was detected. The unit ID for which there was a response received is 0R255. We can see that we have some information about the hardware modules. So actually 2030 is the model of the CPU. So the scan is still running. When it reaches the .50, we'll have some information about the Siemens PLC. Is it working? Yes? Okay. So I'm not going to wait. I'm just going to scan the .50. And same way for the Siemens, you see that some information was already gathered, like the firmware version or the hardware version of the CPU. You should get the same results. No? Okay. It's funny. The only difference is that I'm using this cable and you're using the Wi-Fi, so maybe that's the source of the problem. Did it work for the Schneider? Yes, and not for the Siemens? Okay, quite strange. No, actually it's PLC Scan. It's the, let's say, the standard version. I downloaded it 2 weeks ago, I think. Okay, so we just saw 2 different ways of identifying PLCs on the network. There's a third way, which is called SNMP, and I'm going to show you how. Actually, by default, the PLC responds to SNMP requests. So let's say in Kali, you have a tool that is called SNMP check. You use the switch T and then you input the IP address. So in this case, SNMP check minus T and then the .5. And it's going to give you a lot of information. So if I start, you have the hardware version, then you have the network configuration, and then something that's quite interesting, you have the different network routes configured, and also all the listening ports on TCP and UDP. So instead of performing a network scan, you can just perform an SNMP request and it will tell you what are the ports available. So that can come handy also. I can do the same on the Siemens. I think I should get similar results. You see that there is 3 different UDP ports. I actually do not know what the last 2 are used for. And I do not have the list of listening TCP ports. So did not have the same level of information, but that's kind of interesting to know. Just by sending a SNMP request, you can gather interesting information.
If you have connected systems to the PLC, in that moment you will also get the established flow and you will also get the PLC.
Yes, exactly. If, for example, maybe it's a good idea. I'm going to try to do that. So I will launch Unity Pro, which is Schneider programming software. Okay. I'm going to try to connect. So yes, now I'm connected. I'm going to start the PLC again. And then we set on .5. So yes. Wait, that's me. That should be me. So you actually have the IP address of the programming software. And also someone on the FTP. Yes. I do not use it during this demonstration, but yes, I think it should be a 51 or something, the IP, between 50 and 60, I don't know. So apparently someone just put the PLC back in stop mode. That's why the light shut off. Okay. And back on. Okay, so next what we can do is try to take a look at those, let's say, interfaces that we discovered. For example, the FTP, the HTTP. Try to find some vulnerabilities. Once again, everything that I'm going to demonstrate is already known, so no 0 day today. Okay, so let's take a look at the web interface. Actually, I think it will not work on your VM because I failed to install the Java Mozilla plugin. And the web interface of the Schneider heavily relies on Java applets. So as you can see, it really looks like the one from the internet. And for example, if I try to go to the monitoring tab, I just have 2 options that are called data editor. I'm going to click on the standard one, and then I have a pop-up that asks me to input some password. So do you know the password? Did anyone try to guess the password? Sorry? Nope. Yes. And the password? Nope. User. This can be changed, of course. Yeah. So here you can see that you have a nice Java applet that should allow you to perform some kind of modification on the PLC. You should be able to modify some data. I think the value of the register and the coils. What else do we have? Basically, you can see what the PLC looks like if you're not just near the PLC. You can see that it's in run mode, and then you have an input-output card. Some information about the firmware. And in the setup menu, you can modify some of the things, like the HTTP access rights, and specific passwords. Okay. So now what we can do is, let me go back here. So as I told you, there is a lot of several Java applets on this web server. If you look in the files directory on the VM, there's a subdirectory that is called jars, and that contains all the Java applets that I recovered from the PLC. So what could be interesting to do is try to, let's say, decompile those applets or perform any kind of analysis to see what is in the applets. So the most basic one would be to perform a string query, of course. So I'm going to look for any word that's longer than 6 characters in the applets. And here you can pick whichever you want. I'm going to try this strings.
Will this work in a compressed file?
Sorry?
Will this work in a compressed file because it's a zip file?
Yes, it works. We're going to see it. I pipe it into more. So as you can see, you can find some information, and what we are going to look for is maybe, I don't know, we could grab for password or username, things like that. Anyway, you can see that you can recover some kind of information. I think you also should have on your VM, let's go into the tools directory. You should have something that's called GDGuy, which is a Java decompiler. So on my VM it's not working, but you should launch it. I'm going to launch it on my host. So if I open the same jar file with the Java decompiler, and I take a look, let's say maybe at the, I do not remember where it is, there is a MISC package, and then global config could be interesting. So as you can see, there's something called FTP logging and FTP password hard-coded into this Java applet. So good luck for changing the password. And as suggest, we try to connect to the FTP service using those credentials to see if they really work or if they do not work. I think you already know the answer. Here you can find the creds. The username is sysdiag and the password is factorycast@Schneider. So with these two credentials, you should be able to connect to the FTP server of the Schneider, and then you can try to find all the files that you want. You will also be able to find a file that contains the word user, which is the username and the password required for the web interface. Sorry, it's too much complex for password. So you can see a lot of things. And in the RDT directory at the root of the FTP server, you can find a file that's called password.rde. I think it's already in the VM and it only contains the word user. Let's see, let's go back to the slide. Okay. So that was a few examples of what we can do with the standard interfaces. And I think now it's time to move on to ICS-specific protocols and vulnerabilities. So yes, let's say for the Schneider, what we can try to do is modify the value of some registers to be able to put the lights on. As you can see, there's only one that is on at the moment. I think 2 additional lamps can be turned on by modifying the Modbus value. And for the Siemens, you have in the tools /scan7 directory, you have 2 specific tools that I wrote for the Siemens, and you can also read the different values and modify the values. So of course, if everyone does it at the same time, it's going to be a kind of a mess, but I think we can try. Okay, so I'm going to use mbtget to, let's say, read the values. Okay. And now I'm going to try to modify some values. So clearly this depends on the way the PLC was programmed. So for example, in my case, I can tell you if you change the value to 1, you are just to find the right address, and it should put the other lights on. I think it's the address 9 maybe. Yes. And there should be another one, maybe 8. Nope. 10. Yes. The last one is broken. So I'll let you play with it for a few minutes to make sure that it works. Of course, at the same time, you could be using Wireshark to take a look at the data packets, but it's exactly the same as what we've done with the simulator. So for example, if you use the same command but you replace 1 by 0, you should be able to turn one of the light off. Yes. And if we all do it at the same time, it's going to go crazy.
What is the highest frequency possible?
I have no idea. Actually, it depends. Does not depend on the PLC. I use some kind of electrical relays because the PLC uses 24 volts for the outputs, and the lamps only use 12. So I think if we do it all at the same time, maybe in 2 or 3 days we're going to break the relays because they have a limited lifespan, but that's all. The PLC is not going to be broken.
The network will be down.
Sorry?
The network probably will be down.
Yes, also, because that's, let's say, a home router, so yeah. Okay, so apparently that works. Then we could also try, something, it's also interesting. Whatever you do, I think there is one light that you will not be able to modify. Why? Because if during the program that I put in the PLC, I said, for example, this light should be on, the PLC has let's say a CPU cycle. So I think it's around 20 or 30 milliseconds, it will check and it will, let's say, reprocess all the program. So even if you can turn the value to off, 20 milliseconds later it's going to turn back to on. So you, with your eyes, you cannot see anything happening. Okay, so now for the Siemens, if you go into the Scan7 folder, you can see, that you have several Python scripts that I wrote myself. If you use the read new and you input the IP address, yes, I should be able to see the values of the input and the outputs. I'm going to just make a little test and flip the two first switch. And if I do it again, yes, you can see that input 0 and input 1 are now set to 1. And also the outputs. That depends, of course, of the programming software. Does that work for you also for the Siemens? Because we had problems before with the PLC scan.
For the write out, can you show it?
That's the request that's written. It's a Python, and you use then the script. Okay, great. So now, as you can see in the directory, there's also a script that is called write output. So I'm going to try to use that one. And the parameters, the first one is the IP address, and the other one, let's say it's, yeah, I'm not a really good programmer, so there are 5 outputs for this kind of Siemens PLC. So here you just have to input a 1 for each of the outputs you want to put to on, and if you put a 0, that's changed to off. So I think this will shut the lights off, and this will shut 2 or 3 on. Yeah, it's 3. But again, anyone doing the same with a different value, let's say the last one gets the last word. And this time on the Siemens, the relays are actually part of the PLC, so I'm sure if we all send different commands, we can break the actual PLC. Sometimes, someday. And there is a nice clicking also. Okay, so these scripts are not online yet. They will be on my GitHub maybe this weekend, I don't know. Of course, it depends on the configuration of the PLC. I use a specific library also that's called Snap7. It was developed to allow third party to develop software that communicates with PLC. So I'm just using Snap7 and a Python wrapper. So it's really a basic script. Do not look at the source code. It's shit, but it works. Okay, so this was for the first part, and then I have 2 other things to show you. I think someone already tried the first one, which is the Metasploit module to put the PLC in a stop or start mode. It's actually an action that is done in an unauthenticated way. Sorry. So I'm hoping I have one MSF console still open. And no. Yes. Okay, so this time we're going to use, it's also an auxiliary module. It's in admin, Scada, and then modicon command, I think. So if you take a look at the info, it's actually something that was discovered by Digital Bond. I suggest by running this module, you also run Wireshark. I'm going to do that. I'm going to listen to one of my interface. I think this one should do. Okay. So of course I have to set the target. It's not this one. And I just type in run. And it shuts down. Okay, so now I'm going to take a look at the Wireshark capture. Okay, So as you can see, sin, sinac, ac, and then some Modbus queries. If we take a closer look, same as before, transaction identifier is 0. But that's interesting. The command that I sent actually uses an unknown function code, which is 90 or 5A in hex, to send specific commands to the Schneider PLC. So that's an old vulnerability. To my knowledge, it has never been fixed. And then when you set mode to run, you can put the PLC back to run. Sometimes it will not work right away because there is some kind of reservation mechanism, and if I put the PLC into stop mode, I have to wait several minutes to set it to run again, depending. So that could be also kind of a big deal for your clients, because if all the PLCs are shut down, then you produce nothing on your plant or factory. So. Okay. Then the last one I want to show you, still in auxiliary admin Scada. So it's called Modicon Stux Transfer, and there is an _ASO version. So it's a version that I modified. I think it's in the info. As of today, it's not part of the Metasploit module because let's say it's not really greatly coded, and also it does not work all the time. It's a modification of the original module by Digital Bond because there was some specific issues in the module by Digital Bond. Some of the counter were not right, so I just modified some of the code. And I also added an action that allows to gather information. So let's run that. And let's see if it works. As you know, the PLC is in a stop mode, but yes, it works. So you can recover the PLC model. Project name, as you can see, it's not correctly decoded. You can see that it was done using Unity software version 5, and then you can see the comments of the project. So that may or may not be interesting. What's really interesting is to be able to set the action to download. Then I just have to put a file name also. I'm going to say /root/test.apx. So this could take some time. I'm going to take a look at Wireshark to see what's going on. As you can see, more Modbus TCP requests, still using the function code 90. So I'm actually retrieving the program of the PLC using a Modbus command, which is unauthenticated and unencrypted. Okay, so apparently it worked. It's a problem of a decision that someone made to use an unauthenticated protocol to allows arbitrary download of the program file. Yes, that's actually not part of the Modbus protocol at all. It's not in the specification.
So I guess in the Siemens it's not there. So you cannot do this compare.
Yes, actually this specific model of Siemens does not support Modbus by default. So yes, I cannot use this vulnerability. However, in the past, I think that someone who presented at Black Hat US in 2011 demonstrated some vulnerabilities like unauthenticated start and stop on the Siemens and different kind of denial of service. But I'm not sure he was able to download the program. I'm not sure about that. So as you can see, test.apx is just a classical file. Let's see, we're going to try to take a look at the hex data. So nothing really interesting, at least at the beginning. Here you can see that this is the project name of the program. This is the comments that I put in, the Unity version. So I think the attack worked. Then you will see a lot of error messages written in French. I do not know if it's in French because Schneider is a French company or because I'm using a French version of the software. I have no idea. So yes, here you can see that we recovered the program. The thing is, at the moment you do not know how to use it because APX file will not be opened directly by Unity Pro. So what I did to be able to exploit it is create a dummy project in Unity Pro, archive it, and then it's a file with the STA extension. Then you just rename it to zip, you unzip it, and you can see what's inside. I think I have it on my VM, maybe. Nope. I have to switch to the other VM. Okay. So here on the desktop I should have it. Yes. So here you have a classical STA file. So that's an archive of a Unity project. Okay, now it's a zip file. So you can see there are different files. If you go to binapply, you have BIM station.apx. So actually all you have to do is replace this apx file by the one you just download with the module. You rename it to station.apx, and then you can open the project in Unity. So that means you have, let's say, the whole source code of the PLC project on your computer. So that's kind of interesting. What's also interesting is the vulnerability allows you to perform just the opposite. And by the opposite, I mean reprogramming the PLC using the same functions. So that's also kind of a big deal because you could, let's say, seriously disrupt the industrial process by doing so. So if you want to use the Metasploit module, you can do it. But if several people do it at the same time, I'm not sure it's going to work. But you can try. Be my guest. Okay, and that leads me to the conclusion of this workshop. I think I've demonstrated a lot of vulnerabilities, of bad behavior in ICS. Now the question is, what can we do about it? You can try to do some things. You have to know that it's not really easy. But network segmentation, for example, as I demonstrated with Shodan, you can find ICS on the internet. That's not normal. I do not understand why it is the case. So that's the first step. Actually scan the internet or use Shodan to find your own ICS and be sure that they are not on the internet. Some of my clients did, and they found some interesting things. Secondly, you should also restrict the access from the corporate network to the ICS to prevent attackers from getting in. For example, when we perform penetration tests, like 95% of the time we get admin of the Windows admin Active Directory domain. So if it's easy to go from the corporate network to the ICS, we're going to also be admin of your ICS. So that's not acceptable. Patch when you can. So yes, even if you do it only once a year, try to apply security patches on your PLCs. On the Windows machine, you can also do the same. If you have to just use a dedicated WSUS for your ICS, that's not a problem. It can be done. Try to apply some corporate best practices. So changing default password, that's something, not everybody does it on the corporate network, but most people do. You should try to do the same on your ICS when you can. Of course, for the hard-coded credentials, you can't. But at least do what you can do. The same for the services on specific model of PLC. You can disable the web server, you can disable the FTP server. Most of the time nobody uses it, so just disable it. And then the most important point, I think it's time to start monitoring the security of the ICS. So some IPS have specific signatures for ICS. You can also define your own. That's not very complicated. And in order to be efficient, I think we have to start today trying to step by step monitoring some part of it and to be able to make it work tomorrow at a broader level. And so I was looking for a good conclusion, but I did not find any, so I just put two funny pictures to remind us that yes, we can do some things to secure the ICS, but it's really costly, and that's also why people do not do it, just simply. Okay, do you have any question for me now? I think I speak a lot, but I'll be happy to answer any question. You can also still enjoy the lab for a few minutes if you want to try to crash everything. No? Okay, thank you.